Hello everyone, January 24th. Alright, let's do this. Oh, I thought it's Tucson. I got excited. I was like, yeah, today is the day that we can deal with this, but no, probably not. Alright, we're gonna make lexicographically smallest array by swapping elements. Zero index array nums, and a positive integer limit. One operation you can choose any two indices and swap them. If there's no requirement of I smaller than j. Just pick two such that their difference is smaller or equal to the limit. Return the lexicographically smallest array that can be obtained. And everybody is... Wait, hold a second. Lexicographically smallest. So 2103 is lexicographically smaller than because they differ index. Oh, wait, hold on. If the first position where A and B differ, array A has an element that is less than the corresponding element in B. Okay. So basically it's just we get numbers and we can always if there's no restriction on the limit, we can just sort it. That will always be the smallest. But with this with this limit, so there are things that we cannot do. For example, I know the smallest is this, right? The smallest is this. So so 1 is in the right position, so we don't move it. So 3 is not in 5 is not in the right position. So 5 should be in this position. Ooh, 5 should be in this position. Okay, so I have the position that 5 needs to be in. And then I need to know yeah, so I know what 5 needs to be in. And I want to know if 5 can be in one of those positions. So in this case, 5 needs to be in this position, so I check this. So this is a 3. So you say limit is good, so I swap them, so now it becomes 3 and 5. Right? So 3 and 5. Now after we swap, we stay on this position and just to check, oh, it's in the right position, and this, so we can swap again. So we can get to the smallest. Alright, let's try the second one. The second one is given us 1, 7, 6, 18, 2, and 1. Smallest is 1, 1, 2, 6, 7, and 18, right? So this one, good. So 7 need to move here. But limit is 3, so I cannot. Right? So I cannot. So this one cannot move here. Then we need to know where I can move. Right? So technically, hold on, maybe we should go here. So this position should be 1. Alright. Then we check where 1 is. Yeah, so it should be 1. So I check 1 here. And so I know 1 is here. So I want to know any can 1 be swapped with this? No, I cannot. So I keep going. Can 2 be swapped with this? No. Can 6 be swapped with this? Oh, the answer is yes. 6 can be swapped with this. So I look in here, finding 6. Then I swap these two. Okay. Next, we are at 2. And I cannot, so I'm at 7, so I cannot swap this. So we need to find the value that I can swap with this. So basic limit is 3. So it has to be 4 to 10, right? 4 to 10. Now 6 is already used. So I need to delete this one because it's already used. Because 6 is already put in the right position. So this can now go. So nothing. Nothing can swap this. Right, nothing can swap this 7. We'll just have to leave it be. So move on. This one has considered this 7 has considered her as well. Now I come to 18. So basically this is the one I can move. So I do 6, right? And next one, we need to know what is the smallest so far that we can move here. And the smallest we move here so far is you know, we have 1, 2, and 18. Right, 1, 2, 18, and then none of them can move here, so it has to stay here. Now for 18, we have 1, 2, none of them come here, so we have to stay. 2, 1 can come here. Okay, so let's think about one more time. So we have the first position, right? And we want to know if the smallest can come here. Right, each time we want to ask if the smallest can come here. And so we have the sorted array. So we find the smallest. If it's equal, then we're good. We move on. Right, we'll move on. And we need to find the next smallest. Can we come to this position? We cannot. Right, 1 cannot come to this position. So basically, what's the smallest one that within the range that can come to this position? Right? So I'm at 7, and my range is 4, right? 4 to 10 is my range. So I want to know, do we have anything between 4 to 10? The one that we have not used yet. So I go through I go through. I need to find if there's anything between 4 to 10. I want to find the smallest that's in 4 to 10 in this range. So I can binary search for 4. Okay, so something has to be bigger than 4. So I binary search, and we find the first one. Right, we find the first one, and we ask whether this one has been used. In this case, this one has not been used, so we say, okay, this will be here. So now I have to go back to the original array, right, to find the position of this, and then swap it, right, and then swap it. Okay, now we swap it. Okay, now we swap it. So this one will be 6, right? Now I move on to the next position. So the next position is now becomes 7. Now we ask the question, what is, so again, 7 again. So we'll do this again, binary search. But binary search, ordered map. We can do ordered map. So once you're used, you just remove it, right? We order the map and define something that is just bigger than this. We find its index, we swap it, pop it. Because that's like what we used, right? And then in this case, we basically don't have any, right? So this one, setting stone, right? Setting stone. And once it's setting stone, then its position need to be popped as well. Then we move on to the next one. And this, we can binary search, not binary, yeah, we can search again, and then it will give me nothing, right? Or give me nothing, because if we search for the first one column is the same thing, and we need to keep moving until we find something. But hold a second, we want to find something smaller than us, right? If it is just us, then no need to swap. Okay, so here is the thing. How do we use ordered map? I believe this is an ordered map. Okay, map is already ordered. Map is already ordered. All right, how do we binary search an ordered map? I don't know if it's even possible. Lookup. Lower bound. Okay, so map lower bound. Lower bound 2 will return to 2, right? So the lower bound is a built-in method to find the first element in map whose key is either equal or greater than a given key. No, okay, so I find it, and if it's bigger than me, then if it's bigger or equal to me, then if it's not, then we use, okay. I think we have this idea of how to do it, and we just need to use, I want to say we use a stack, but stack requires us to, it doesn't matter. It doesn't matter from where you pop it, right? It does not matter because they are all the same. Okay, then we'll go with stack. All right, let's try this. We'll go with stack. We'll go with stack. All right, let's do it. So we need a map of integer and stack. We call it positions. How do I initialize a map? Map something. How do I don't know. How do we initialize a map? I actually do not know. Initialize map. Yeah, std map and this expected qualifier. I don't know what that means. Maybe I need a map. Oh, I need include. That's why. So I need include map. It still said I probably need stack as well. There you go. I need a stack and a map, right? Then we need to say I0 I smaller than nums. That's how I probably can use n for this. Let's do that. Nums dot size, right? And I plus plus. And what I do is position dot. Actually, I'm not sure how to do this. Insert key. Huh. We have to do pairs. Oh, that is interesting. We have to do pairs. Really? Update existing. Insert a new thing. I can do that. I can just do that, right? I think I can just do nums I, right, because it's an integer, dot push this, right? So that helps us get all the positions, and then we will create std vector int res. Can we say nums? I guess we can. Basically, we copy nums, right? And then we go through. I wonder. Maybe we don't need to do this. Maybe we just go through. No, I do think we have to. All right, then we say for int I0 I smaller than n, I plus plus, right? So res I is the current value. What I need to do is find the smallest thing that we can do. So we can say current is res I, right? Then we need to say auto iterator equal to position dot lower bound current minus limit, right? Current minus limit. I think this is the use case. Lower bound, yeah. So we'll do that. And actually, I don't think I need current. I think I just do res I, right? So this is my iterator. How do I use this iterator? Okay, the first and second, right? No, first and second. So we say it if it first, that's the key, right, is smaller than res I. So this means given the current value, I remove limit, that's the smallest, and I try to binary search in the map to see if anyone is bigger or equal to that. So we find the key. What if it's oh, it will not, right? So we find the key that is bigger or equal to your target. Oh, we probably can do target, right? We can do target. That makes more sense. So we do target, right? And then we say if it's smaller or equal to target, that is not right. No. It is smaller than the current one, right? Then this is the smallest. Okay, then this is the smallest. Then what we need is to find its index j shall equal to position it first, right? Actually, I can do second. Yeah, I can do second. I can say it second dot pop dot top and it second dot pop, right? This is the position. I can do swap. I can maybe std swap. Do we have that? Yeah, swap. I don't know how to use swap. Swap. How do we use swap in a vector? Okay, this is a vector. Int foo, int bar. Okay, hold on. I don't think this is the one. So swap vector elements. So vector, we just, oh really? Swap elements at index this and this. We just directly put these. Ah, so I think the address that holds the value gets swapped. Okay. So we'll swap res I and the res j. Right? We'll basically swap them, and once we swap, yeah, then it's good, right? This is good. And we say if, maybe we should do it earlier. So we pop it, right? So once we pop, we can say if it second dot empty, then we say pus dot remove, delete, erase. Okay, I actually don't know how to use erase. Erase an element, map erase, iterator position, or you can erase it has to be an iterator. It has to be an iterator. So we say erase it. Perfect. All right. So if this iterator it becomes empty, then I erase it and I swap it. This is if this iterator is smaller than that. Else, right? We can say this is we can find a smaller value to swap, right? Else basically is there is no other value to swap. So if that's the case, then we will use the current one. Then we say how do we find the iterator to the key? Okay, map delete key. Oh, I can erase key. This doesn't tell me how you erase key. Ah, this is key. So I have this, remove the element with key to, I can remove the element with key. Okay, so in this case, I need to say position nums I, right? Nums I. Ooh, see, this is the problem, because you go left to right and it's gonna pop. Yeah, I think you have to go right to left if you want to make it correct. Let's go right to left. It doesn't hurt, right? It doesn't hurt. So now I can just say position this thing will pop, right? Because we used the I already, so we pop it. And if position nums I dot size, not dot empty, it become empty, then position dot erase nums I, right? But no swap is needed. Then we move on to the next one, and we move on to the next one until we hit everything. Then we'll return rest. All right, let's see. Well, we have this data structure, definitely make these things a lot easier. Yep, I think this one looks pretty good. Two 948. Take advantage of the ordered map in C++. Right? We store, use number as key, and the value is a stack of positions. Right? For each position in nums, for each number, right, we find the smallest number that is swappable with it. The lower limit is set as nums I minus limit. If such swappable number is available, right, we swap it. Otherwise, we use the original one. Note that once a number is set in stone, we must pop its index in the map, in the map's value. And if a number has all its indices popped, the number must be removed from the map. So let's call it ON, and each time we do a lower bound is gonna be a log. Yeah, we call it ON log n. Technically it's not ON log n, I think it's ON log m, right? Where n is equal to len nums and m is equal to len unique nums. Alright, run this one more time. Hopefully we got a pass in the first shot. We'll try it. It's pending, it's judging, and it's wrong. Okay, that is very painful. We only passed 7 test cases. Oh my god, that's pretty bad. Okay, what went wrong? 160, 34, 84, 62, 56, 39, 76, 49, and 38. So the right order will be, I think 34. Oh, wait a minute. Why I would output 62? I'm at 60. 60 minus 4 is 56. There's no 56. So the smallest is 60. Alright. That is something we need to debug. I think it's just, it could be a skill issue because I not very familiar with how this thing works. Well, we'll get it. We'll get it. And limit is 4. Yep. And this is going to be lexical this nums and limit. We don't need this. Okay, then we need save this and let's go set this here. Okay, 25. Okay, let's take a look. Vector is here, position. This is what I'm interested in. Do I have what they are? Actually, we don't. Huh. I have some error here. I do not know what happened. Expected unqualified ID. What? 34. It's a stack. I have no idea what happens here. 38, 39, 49, 56, 60, 62, 76, and 84. Okay, these are actually not bad. Okay, this is actually good. Let's move it up. All right. Okay, so we come in. Oh, wrong thing, F2. All right. So res I is what? I is 0 and I mean minus 4. So minus 4, it. What is it? It is first is 1. Yes. And then we say, is it larger? No. So now we'll pop it. Yes. So now we pop 1. That's good. Now I become 2. So the second one, 60, right? 60 minus 4. So I think it will point into 56. Oh, there is a 56. Yes, there's a 56. Smaller. So J. So 0, 1, 2, 3, 4, 5. J is 5. Right? And then we'll pop it. Then we'll remove it. 56, we'll remove it. Right? So I is 1. So now we'll swap them. Okay, now we are going to swap them. I need to see the result. Where is the result? Position result is here. Alright, so now we're gonna swap them. Yep, we swapped. That's good. Oh, after we swap. Gosh, dang it. Dang it. Now 60 has a new position. Right? 60 has a new position. Now 56 is gone, but 60 has a new position. Which means I need to... Oh. So it has to be a set. Because I need to remove the previous and put in a new one. Can we do better than just use your set? Yeah, I see what the problem is. Because now 60 is at position 5, but in the map 60 is still 2. Right? 60 is still 2. So when we go to this position, go to this rest, so we got a 5. And 60, yeah, it's gonna be 62, right? So instead of swapping here, I swap into the, yep, that is the problem. I don't want to do it, but I guess that's the only way. So instead of doing a stack, unfortunately, we have to use a set. And then for here, it doesn't really matter. We can just, wait, what's a push? What's that? Add? I honestly don't know. How do we use set? Insert. Right, so insert this. And blah, blah, blah. We do the same thing. And then we say, find a smaller j will be, how do we just remove, it's because it's a set, right? How do we just remove a value in a set? So we say remove a value, get a value, right? Get a value, pop a value, pop from set. Is it possible? Begin, get a value, and erase it. Okay. So I can say the second dot so we say it. I have already it. We have another auto set it. Is it second dot begin. Okay. So this will be set it star set it. Then this will be erase set it. Set it sounds so stupid. IIT or ITT, iterator. That actually sounds better, right? So ITE, we do ITE. Okay, so we get a value out, we remove it, and we check this is still fine, then we'll swap it. And regardless, we have to pop it. So this is to get this one out, right? And after we swap, right? After we swap, then we need to say update the position of the original number. Update the position, the index of the number to be swapped. Okay. And then update the index of the current number by doing this. Position nums I dot erase I. Then position nums I dot insert j. Then we swap it. Right? Swap the two numbers. Oh, there's nothing? Then we just need to remove it by calling erase. Yeah, because in that case I find that we just need to remove any one of them. Here I know which one to erase. I just erased this. Okay, let's give this one a shot. See if this one works. Use this test case. Okay, let's try this one. Still not right. It's a different problem. So 52 minus 14. What's 52 minus 14? It's 38. So we have 38. Ah, I see. So you have to keep swapping until... Oh, yes. Yes. You have to keep swapping until you can't move forward anymore. So int I 0. Alright. And then this one will be I smaller than n, while I smaller than n. We do this, blah blah blah, and then so we swap it. Then we code back to the same one. We try it again until we hit here. There's no value to swap, right? And then I plus plus, right? If it's value to swap, I'll swap it. But if it's no more value to swap, then I'll keep it. Okay, so let's try one more time. Let's add this as a test case. That's still not right. It's interesting. But for sure, the first one we got a 38. And then 38 minus 14 is 24. But the next smallest is 27, so I got 27. Right? 27, and then we come here. How come it's become 88? What in the world? Hold on. 4, 52, 38, 59, 71, 27, 31, 83, 88, and 10. Alright? So 14. This is 14. So the first round I got 38 here. I got 52 here. Right? And 38 we got 14, which is 24. So anybody larger than 24, we have this. So we swap this, 27, 38, right? And 27 minus 14 is 13. And the smallest of the 13 is this, so we move on to 52. Now 52 minus 14 is 38, so I'm supposed to move 38 here, right? Should be 38, 52, right? And then 38 again, it's going to be 24. But now the biggest than 24 is going to be 31, right? It's going to be 31. So that's why I'm 31 here and 38 here. Right? How Gaon got to 88? What in the world? We got to 88. And 31 minus 14 is 27. No, 17. Right? 17. We don't have any. So 31, move on, 59. That's probably getting to 38. Okay, we need to debug this again. Lord. Alright, that's not making me happy. This does not make me happy at all. Alright, we'll build this again. And then... okay. So it's 4. Erase. I move on. I go to 1. It is 38. It's correct. Right? And anyway, J. What's J? Where is J? J gave me 2. That's good. Huh. I erase 38. Because I pop 38 out. Okay. And then then 38 comes to this position, right? But I already removed 38, so 38 doesn't really have an index. Thirty does not have an index because I removed 38 already. Hold on. So basically, I remove it, okay, and then I don't delete it. I do not delete it. Okay, so I do not delete it because I erase it, but I do not delete it. When update of the current, update the index of the one to be swapped. So we'll erase that and second dot insert I. Right, well, insert the new one. This one is erased. Actually, it's actually going to be better, which is called J and I, right? J, I. Can we say something like this? I'm not 100% sure, but feels to me that this is cleaner in terms of, right? So we get a J. So we update, so we erase J input I, erase I input J. Then we swap it. Nobody gets removed. People only get removed if you hit here, so that we don't deal with this anymore. Okay, let's give this a shot. Uses test case. That ain't right. What the hell? Okay, I don't know what happened. Let's build this, come back, debug it. The first one is easy. Okay, next. Okay, what's J? J is 2, which is correct, right? J is 2. So we say, well, erase, add, position, erase, add, it's good, swap them, keep going. So now I is still 1, and it is 27, yes. Okay, so J is 2. Actually, we haven't got J yet. J is 5. Right? J is 5. I is 1. J is 5. Do this, do this. We'll swap. Good. Next. 7, it. I cannot find another one because minus 14 is 13. We don't have another thing bigger than that. So in this case, 27. We'll erase. Ooh, 27. What's the second of 27? '27 is not erased. Oh, gosh. I know. This should be Russ. This should be Russ. I have no idea why I make such a stupid mistake. Yeah, that was a stupid mistake. Okay, let's go for it. Oh, we got TLE'd. What? What in the world? Huh. I mean, yeah, because we're constantly going through. All right, so let me read. I don't think there's any mention that. There's no mention. So basically, for us right now, for each position, we're doing multiple swaps, right? Now the question is, can we find one swap? I guess we can, because we can just go multiple steps, right? So we have the current number, and then we just find it, and if it's good, I use that, and then we find it again. We find until we cannot find anymore. So in this case, I have 52, I can find 38, and from 38, I can find 27. All right, and on 27, I cannot find anybody. So we just keep going down to find the one we want. Then we do the whole thing. Okay, that seems promising. So in this case, I think we have to change things again. We will go this one by one. Right, so we say for I, 0, I smaller than n, I plus plus. But here it is something different, right? So we shall say auto it is the first one, right? And then we say while it first. Hold on, I need to feed my cat. So what do I say? I say I get the current value out, right? I get the current value out, and then I say if this one minus the limit, I got that. If it's smaller, then I'll replace the value and keep going until we get to a point, right, where we cannot do this anymore, and that's the one that we will use. Then we do it once. We don't have to, add it back, take it out, add it back, take it out multiple times. Yeah, we go through this while loop. It shall be just some log n complexity. Yeah, I think that shall work. Now it kind of got me thinking, maybe we can even do it, without this map thing. Because it's basically just jumping, right? You have the current value, and then we have limit, or binary search it, we get it, or binary search, and each time we binary search, it's a requirement that it has to be something But if you do binary search, you will have to remove stuff because there are values you don't no longer use. Yeah, I do think it should be the map. Yeah, I don't think there's an issue with the map. It's just the implementation that's not correct. Okay, we'll update it. We'll update the implementation. Do this jumping thing. Alright, let's jump. Let's jump. Okay. Alright, we can say current is res I. Alright. And then why don't you just do while true? No, we don't do while true. We get this one out first, right? Current minus this. We say while it first is smaller than current. Current equal to it first, right? Because we basically swapped to this value. We basically swap to this value. And then we say it equal to position dot lower bound current minus limit. We do it again. Back until at a certain point it first is not smaller than current, which means current is the one that we need to swap to eventually, right? Current is the one we need to swap to eventually. So we know current is the one we want to swap to eventually. Then we need to get the index j shall equal to, I think this one still works. We say position current dot begin, okay, and then so current is not current. Target. Let's call it target. Okay, let's call it target. 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 So we get a target. So we have ij, we have res I, and then we have the target. Now what we need to do is we need to update. So we say here is keep swapping, keep searching, right, for the smallest value to be put at position I, right? And then we need to update the current number, right? Update the current, update the index of the current number. So the current number is nums I. So we say position res I dot erase I position res I dot insert j, right? And then we'll update the index of the target number. So we say position target, right? Dot erase j position target dot insert I. So once we're done, then we'll swap. Right, then we swap res I res j. Okay, so we swapped two numbers. Now after we swap, whoever occupies I need to be removed. So I think there's also a little bit we have settled on current the current value, settled on index I, and remove it from the positions. Right, so we basically say position res I dot erase I. If position res I dot empty, then position dot remove dot erase res I. Okay. So if I and j is equal, then these are moot points. So if I is not equal to j, that's when we do all this. Right, if they're not the same, then we need to do this exercise, remove, add, erase, insert, and then we swap them. And after swap, we need to remove that one, and then we'll remove. Okay, so let's try this one. So first test on the simple cases, make sure they still work. And let's use this test case, make sure it still works. Oh, it's still TLE'd. Dude, how? Too much while loop. Feel like we need a new idea. I think this one doesn't work. Does not work. All right, I am gonna stop right here because I need to go train. I may check the hints, but I feel like I still have something in me to get this one. Because we also have like these is very costly. I wonder if we can do something about that. Or, I mean, basically you start from something and you start tracing, and then you just keep finding, because from this, you find the next, from the next, you find the next, you find the next, you find the next, and all the way down, you have a chain, right? You have a chain until you hit the last one. Then you swap, right? Then you swap. And after you swap, you move forward. And then you have to do this whole chain thing again. Yeah, this is actually not O n log n, because each one you do a chain. That's going to take a long time. Can move from here to the next, then to the next, then to the next, then to the next, then to the next. Is this a graph? Four is by itself. $52 can go to 38. 38 can go to 27. 27 cannot keep going on. Right, this is a chain. And then 59 minus 14 is 35. No, 45. 45. So 59 doesn't have any place to go. $71 minus 14 is 57. 59. So 71 can actually go to 59. Oh, hold a second. 38 go to 27, but 38 can also go to 31. Right? 38 can also go to 31. And then 88 go to 83. That's all right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm missing one. 10. Oh, technically, 10 can go to 4. Right? Technically, 10 can go to 4. So this is kind of the graph that we have. And 59 can go to 52. Minus 14 is 69. So this actually can go to 71. Right? And in fact, 31 minus 14, this can go to 27. Right? Because just as long as it's within 14. Because 14 is 17. So that's kind of the graph. But 17 cannot go to 10. Right? So this is basically we have two links. Okay. So now we have 4. So we're trying to find something smaller. So 4 doesn't have anything smaller. So it has to be 4. Now it's 38. So 38 we can go to 27. So basically we say we remove this. No, 52. So 52, well, we go to 27. Next is 38. Yeah, that's fine. We can just swap. Hold on. Let me redo this. So basically, in this kind of new idea, you're establishing, hold on, this is 38, 27, right? So 4 is just 4. 52 becomes 27. 27. We'll swap. So 38 shall go to 31. Where is 31? 59 shall go to 38. '71 shall go to 52. There's a 27, we already use it. 31 will use it, right? And then 59, the 52 used. Next will be 59. By itself. We do have to swap it. And then 83 should be 59. No, 59 is done. So 83 is going to be 71. '88 shall be 83. And 10 shall be 4. No, 4 is already used. And then 10. Where is 88? I feel like this is the way to go. I sort it first, and then I just start doing swap. So what I don't know is, do I need to swap it? Because if I don't swap it, I just keep moving forward. Yeah, then you will hit a wrong number, right? So you do have to swap it. So I do think we have to swap. Let's do this one more time. Okay, one more time. So there are a few things that I need to know. Last one. After this, we're gonna go train. 38, 59, 71, 27, 31, 83, 88. So let's redo this. All right. We basically have, we'll sort it. Let's say 88, 83, 71, 59, 32, 31, 38, 31, 27, 10, and 4. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll go through this. So this is smaller, smaller. So we do 14. Smaller, 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 smaller. And this is down. So this is kind of the first one. This is the second one. Okay. Now, and I start with 4. We can binary search this. And we try to see if there's a next one. Binary search this. I don't know. Binary search this. Because I need to, basically this, you want to create kind of two things, right? This is 4 and this is 10, 4. Right, so basically we have two things. But how do you know 4 belongs to this? How? There's no key here. Right, how do you know a thing belongs to, okay, so I can create an array of stack, and then I can get another one to say where you belong. Okay, so 4 belongs to this, so I'm looking at here, I look at the last one is 4, so I swap with 4, and then we also have your positions. Right, we do need your positions. Maybe this can be a pair. Right, maybe this can be a pair. It's this and your position. So you'll pop this out, get a position, you will swap. But once you swap, how do you know? Yeah, so it cannot be a pair. It has to be another thing that will store your position, right? Then when you pop this, you get a position out. Yeah, and because this is the thing that you need to swap with, and then you do the swap. And you check if it's equal, then you don't do anything. If they're not, so yeah, this is equal, don't do anything. Next we go to 52. So for 52, you're looking here, because I know 52 belongs to the first one, right? Belong to the first one. And I'll find the last. So I'll pop it. Okay. I'll pop this. And I know what position it is. And I will swap it. Because otherwise 52 will be gone, right? So I will put 52 here. And I will put 27 here. And I will update the position for 52. So 52 has a new position. And 27, basically I just remove this position. Right? So I remove this. And then we go to 38. 38 belongs to this. So we got the last one, is 31. So I'll pop this. Swap. So 38 become here. So 31 comes here. And I update the 38. Right, 38. Now 31 needs to get updated as well. So 31 needs to remove. Right, we need to remove, but we don't have to remove the whole thing. We just remove the set. Right, we just remove the set. So next is 59, so 59 will be 38. Right, so we pop 38. And when we pop 38, 38 already get updated. So we'll do this. So 59 comes here, 38 comes here, so this one gets popped. Next 71, 71 will be 52. So basically 52 will be here, 71 will be here, 52 gets popped. Alright, next is 71 again, and this time with 59, so it will be 59 here, 71 will be here. Right, next is 71 again, but this time it's by itself, so it's the same. I just pop this, right? I just pop this, and then we'll move on. 83, 83 is by itself. Right, 83 is by itself. And 88 is by itself. 10 is by itself. Then we got it. 83, 88, 10. 4, 27, 31. So I think this one might make more sense. I sort it once, right? I sort everything. I start from the beginning, and the current index is 0. We go, 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 go. Once I hit something that is more than this, I break it up. Right, I break it up. Now it's also interesting. I can just have the whole thing, and I can say the end index. Right, the end index in my current thing, the end index, it's just end index, end index, end index. So it can be one array. I just need to know the end index. So when I hit someone, I look into this, we find the end index, right? We find the end index. Well, is that end index or end index? Let me think. If I just put the end index in it, then I pop out the index, and I have the current index, and these two will swap, right? Will swap, and it's not gonna work, because after they swap, right? After they swap, then the other value, I don't know what, like its index needs to be changed. Like I need to go inside the indices. Like I need to swap the two indices. I put this indices into that position, but that is not going to work because I have the linear search, right? I have the linear search. So no, I don't think index is the way to go. I think it should be value, right? It should be value, and we will yeah, it should be value because index will change. Index will change. I don't know, maybe priority queue? What do you mean? Well, no. Priority queue sorted when we get a top into a priority queue. So it's gonna be priority queue, priority queue. Okay, then what? Then we find a current value. We know which index it is in, right? I know which index it is in. So I go to that index's priority queue. I pop the smallest, which I know its index. But you still have to keep track of the index. Like regardless, no matter what you do, right? No matter what you do, you have to know. Dear Lord. Let me think again. Yeah, I think we definitely, because we have to keep track of the indices. Right? There's no way around. We have to keep track of the indices. Okay, I think this one still works, right? So we'll get this, which is so these are the indices of the sorted array. It's different from this. Indices of the sorted array. But as you go, how do you know? How do you know that you are crossing the boundaries? Right? How do you know? You don't. Alright, I think this will work, but I think it probably will time out again. I think at this point, we're 1.5 hours in. It should be time to read the hints. Kind of see what... Okay, it is a graph idea. I mean, we are thinking about a graph already, but and end up we didn't really. No, this is the graph idea, right? So like they have edges. So basically these are the edges, right? And then this is the other edges. But then what? Yes, 4 doesn't have the next, so 4 doesn't get 52. I can keep traversing. But look at this. This is exactly this order. So basically we sorted it and we try to find, so there will be like stretches of available, okay, and we know what each number is in. Then we go from the front, okay, if it's in one of the stretch, right, if it's in one of the stretch, then basically I can swap to the end. Still no. But in this case, like 58, like this belongs to the 0, 1. These all belong to the 1, right? So we just keep searching for the ones, see which stretch it belongs to. So if this belongs to this, but the next one belongs to another stretch, then we can only get one of them here. And the next one will belong to, like, maybe next 3 belongs to, so I can get those 3 coming here. Alright? And then next we have a few. Basically, different stretches cannot cross the boundaries. Yes, that might be the idea. Just the original one, we also have stretch, another stretch, another stretch. So each of the original stretch, we need to find one of the good stretches, and then we take the smallest out, put it in. Right? Take the smallest out, put it in. That's kind of the. So we go, go, go. Mm-hmm. Mm-hmm. Yes. Yes. So we take those, put it in, and yes, like this one is in this, we put the small. This one is in there, put next small. Put this one in the next, up into. So like 52 is in the stretch, 38 is in the stretch, this 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 is, they are all in the, once it's in the stretch, I just keep putting it in, right? Keep putting it in. And this, I think I have an idea. I think I have an idea. All right, so I'm not gonna do it today. It's too late, but this might actually work. All right, I think I'll do it one more time tomorrow. It has been, it's like a habit. Like every Friday, I couldn't solve it in the given time. I have to do it again tomorrow. All right, I'll see you guys tomorrow.